right, the speed of space. Oh, we should say the speed of the universe. Let's just say the speed of the universe. And so, right off the bat, the speed of the universe is faster than light. I'm going to put a question mark because there's a little more to it than that. It's not exactly that. So, at certain distances, the speed of the universe will be faster than light. And I'll have to explain that in the video. Now, how can that be? Because Einstein said it, and it was around 1905, roughly around 1905. He said nothing is faster than light. Well, he said nothing in the universe can go faster than light. But he said nothing about how the universe itself can move faster than light. And the universe is expanding. The galaxies in the universe are expanding away from each other faster than light. So let's go over some terms first. So here's light. Let's just go over some terms. First of all, we have to talk about a light year. A light year. So a light year is, very simply, how far light can travel in a year. How far light can travel in a year. And that's 6 trillion miles. Change the color, right? Let's change the color so it's not coming out to fix that G, right? So there we are, changing color. Light year is how far light can travel in a year, and it's about 6 trillion. Not exactly 6 trillion, but 6 trillion miles. Not million, not billion, but 6 trillion miles. And the speed of light itself, change the color again. Let's use white. See if that works. Yeah, okay. So the speed of light itself is 186,000, fix that 6, miles per second. Remember, it's miles per second. So if you snap your fingers, if you were going the speed of light, which you can't, but if you went the speed of light, light can travel around the world 7 times. That's how fast light is. It's immensely fast. But another thing to think about is the universe is immensely huge. The length of the universe is just beyond description. All right, so if we, make sure we have our pen ready. Let's stick it white. Why not? So, from Earth to the sun around, it averages about 93 million miles away. Just the perfect distance away. And it takes light 8 minutes. 8 minutes. So when you're out there in the sun getting a tan, that light left the sun 8 minutes ago. Right? So if the sun blew up, you wouldn't know for 8 minutes. Here's our moon hanging out here. So when the light from the sun reflects to the moon, it only takes less than 2 seconds. So if the moon blew up, you would know in 2 seconds. All right, and here's Pluto now. It used to be a planet. Now it's a dwarf planet. So if you wanted to go to Pluto, light, let's say, light, make sure our pen's working. Now we'll change the color. We'll change it to red. So light would only take 5.5 hours to get to Pluto. For us, though, we had the New Horizons spacecraft. New Horizon. And the New Horizons spacecraft took 15 years to get to Pluto. So you can see how much faster light is. All right, and here's our solar system. Remember, not the galaxy, not the Milky Way, but our little solar system. So all these planets over here, and this is a very simplified version of it. It's much, much bigger than this. And let's get our pen ready. So we see these man-made space satellites. They left. Voyager 1 left in 1977. We have Pioneer 11. We have Voyager 2 down here, Pioneer 10. So Voyager 1, it took 35 years to leave our solar system. 35 years. Whereas light, man, gotta fix that G. Light could take anywhere around 50 hours to leave our solar system. And Kuiper Belt, this is the belt with comets. It has comets in it and has dwarf planets. Like Pluto, Pluto's a dwarf planet, and technically Pluto is in the Kuiper Belt. And, there's another one even further out, Makemake. People used to say make, but it's maki. And the furthest object we've seen so far, way over here, way out there, with a name called, funny name, just called Far Out. I guess they ran out of things to say. Far Out. Light to get to Far Out would take about 19 hours. 19 hours. No. So 35 years for our spacecraft, Voyager 1, to leave the solar system, and yet 50 hours for light. Right? And here's Proxima Centauri, our nearest star besides our sun. Let's get that pen going. Proxima Centauri, Proxima. It used to be called Alpha Centauri C. Now they call it Proxima Centauri. Some people still say Alpha Centauri C. And because Alpha Centauri A and Alpha Centauri B are nearby, but Proxima Centauri would take light about 4.2 light years. 4.2 light years. So basically 4.2 years for us. And 4.2. So when you're looking at Proxima Centauri from a telescope, you're seeing it as it was 4.2 years ago, which is nothing in space. And a light year, again, remember, let's write it down again, is about 6 trillion miles. So you can do the math. About how far is Proxima Centauri? About 24 trillion miles away. Right? Over that. But there's even further objects. And by the way, Proxima Centauri is in our galaxy. Every star you see in the night sky is in our galaxy. We don't see stars from any other galaxy. And our closest galaxy is Andromeda. Talk about that in a minute. All right, here's Antares and Betelgeuse. Some people say Betelgeuse. Actually, that's the proper pronunciation, Betelgeuse. But we all say Betelgeuse. It sounds better. Betelgeuse is enormous. Look at the size of Betelgeuse. Here's our sun over here. Our sun compared to Betelgeuse, this red giant. And Betelgeuse is 642 light years away. 642 light years away. And when you look in a telescope to see Betelgeuse, or Betelgeuse, that's how Betelgeuse looked at 642 years ago. Just to get you understanding those vast distances. And they say Betelgeuse may blow up one day. And if it did blow up, if it already blew up, let's say it blew up today, we wouldn't know for 642 years. But if we go out in the night sky and we find it has blown up, then it actually blew up 642 years ago. And here's Andromeda, our closest major galaxy from us. And it's slightly bigger than us. It's actually heading toward us. Of all the galaxies that are expanding away from us, Andromeda's heading toward us, and we will collide in billions of years from now. But talking about light, so light, sure our pen's ready. We'll stick with blue. Light would take 2.5, million years. 2.5 million years to get to Andromeda from the Milky Way. Just imagine how long it would take us to get there. We wouldn't even be able to think about it. So we know how fast light is. But now, what about the universe? All right, so every piece of light, every dot of light you see here is not a star. These are not stars. These are galaxies, and they're immensely far away from each other. So when we're talking about the speed of the universe, let's try white. Let's just try white. So at times, the universe could be faster than light. It depends on distance. It all depends on distance. And let me explain that. So let me just put the numbers in first. Let's get we can use that, right? The universe is expanding about 68 kilometers per second here's where it gets confusing, per megaparsec. Per megaparsec. So a megaparsec is just a million parsecs. And a parsec, write it over here, change the color. A parsec A parsec is just about 3.2 light years. And we know what a light year is. So we're thinking of 3.2 million light years. Now, what does this mean? Let's get a clear screen here. So, okay, and let's use that color. Why not? So, the speed of the universe. Speed of the universe. Now, it's going 68 kilometers per second, which is not the speed of uh, light. It's much slower than that, per megaparsec, right? So when you get at 1 megaparsec, it'll be going that speed. But if you go out, remember I said it's about distance. So if you go say 2 megaparsecs, then the speed of the universe will increase to 136 kilometers per second, right? Just double it. And if you go 3 megaparsecs, it'll be 204 kilometers per second. Still nowhere near the speed of light. You would have to go at least 3,847 megaparsecs to travel faster than the speed of light. So, yes, at a certain distance, the speed of the universe will exceed the speed of light. So, to sum it up, the further you look out in the universe, the faster space is expanding. And if you just review this, if you want to, again, at 68 kilometers per second, at 1 megaparsec, that's how fast it's traveling, 68 kilometers per second. At 2 megaparsecs, it's 136 kilometers per second, and so on, until you get to 3,847 megaparsecs, and it's traveling faster than light. Let's look at another diagram. Let's clear this out. So let's say we have our universe. We have what we can see. So this part here, this other part, we can't see anymore because, and all these are galaxies, let's say. All these galaxies we can't, looks like a donut, right? So only the galaxies in blue, we can see. Because let's say this one right here, bring back the green. This galaxy, the light from this galaxy is moving toward us, but space is expanding faster than it. So the light would never get to us. So think of it like this again. Maybe we'll do another. Let's say that we have a galaxy A, we have a galaxy B, and C and D and stuff like that. Well, let's say in a billion years or so, we can still see A, barely see B, barely see D, but we can't see C anymore. So the light from C is trying to reach us, but again, the universe is expanding faster. And then maybe again in another billion years or more, C is probably extremely far away from us. Now we can't see D and we can't see galaxy B. All right, let's think about it again. So if this was, we should have our pen ready first. So here was our visible universe. We can see all these stars. And then over time, now we can only see these. We can't see those that we used to see. And then it just keeps going. And then another billions of years, we can see, should have used purple, right? We can see these stars, but we can't see those stars. And it gets more and more until finally we see only darkness, right? So, by the way, the universe is expanding outside of our galaxy. Our galaxy, or the stars in our galaxy, are not expanding away from us. All right, so again, the stars in our galaxy and even the Andromeda galaxy, they're not expanding like the rate of the universe. There, and so I said before, Andromeda is actually coming toward us. And don't worry, it's in 4 billion years. So in 4 billion years, Andromeda will hit the Milky Way, and they'll create a new galaxy. So if you're doing anything in 4 billion years, I would change the date on that one. Okay, that's the speed of the universe.